Hello and welcome. We're doing 10.4 polar coordinates and polar graphs. You might remember this from Math 127. This is the topic of Math 127. Well, one of the topics of Math 127. So, polar coordinates. The pole or the origin is a fixed point called O in a plane around which the polar coordinate system is constructed. So, there's our pole. Polar axis is a horizontal ray initiating at O and going to the right. So this is the polar axis. Any point P in the plane can be expressed, or can be assigned a polar coordinate r theta, where r is the distance ounce and theta is the angle. So r is directed distance from O to P, and theta is the directed angle counterclockwise from the polar axis to the segment OP. Radial lines are lines through the origin, indicating the radius through the concentric circles. So, radial lines. Unlike rectangular coordinates and polar coordinates, the points are not unique. So in Cartesian, we have x, y, and that defines one point. Nothing else will define that point. But in the polar system, many things can define that point. So if you have something here that's at 1, 2, 3, so 3 pi over 3 would also work would be 2 pi plus pi over 3, which would be 7 pi over 3. And again, you can keep on 2 pi, go back 2 pi. Or you could say it's negative 3. So negative, come up with this angle here, which is 4 pi over 3. So negative 3 puts it back that way, 4 pi over 3. In fact, because r is a directed distance, negative r theta represents the same point as r plus theta, r comma theta plus pi. That's what I was describing here. So if you have negative 3, 4 pi over 3, it's going to put you there, just like 3, 4 pi over 3 plus pi, put you back there, here. As a rule, r theta equals r comma theta plus 2n pi, so it could be 2 pi, 4 pi, 6 pi, or negative 2 pi, negative 4 pi, negative 6 pi. Also, r theta would be negative r comma theta plus 2n plus 1 pi. That's like pi, 3 pi, 5 pi, all the odd ones. Theorem 1010, coordinate conversion. The polar coordinates r theta of a point are related to the rectangular coordinates x, y of the point as follows. X equals r cosine theta and y equals r sine theta, where to go the other direction, tangent of theta is y over x. So you could say theta would be arctangent or tangent inverse of y over x. And r squared equals x squared plus y squared. Now, it's important to know that this may be a reference angle. So check the coordinates. Or check the, I should say, the quadrant. I want to point out, though, just recall that arctangent produces values from negative pi over 2 to pi over 2. So if something happens to be in the second quadrant, it's not going to show up quite right. It'll show up as being in the fourth quadrant. You have to add pi to that. Okay, example 1 says plot the points in polar coordinates and find the corresponding rectangular coordinates for the point. So 2 comma 7 pi over 4. I usually go with the angle first. 7 pi over 4 is right there. This angle. And 2, so we're 2 out. So here's 0, 1, 2. And the next one is negative 4, negative 7 pi over 6. So negative 7 pi over 6 is going to be coming back this way. It's on this line here. So on this line here is our negative 7 pi over 6. Maybe we should change colors for that. Go to red. And then it's at negative 4, so it's not up here at 4. It's 1, 2, 3, 4. So it's not there. It's going to go back the other way. Negative 4, 1, 2, 3, 4. And let me write the other one down again. Now it says use the angle feature of a graphing utility to find the rectangular coordinates for the point given in polar coordinates. So there is a feature in the TI-89 I'll show you here. Here's my TI-89. Let's turn this on. Okay. The way we're going to get there is through the Math menu. The Math menu is found here. It's on 5. So if we hit the second button in 5, we'll be there. Second, 5. Let me clear this out first. So second, 5, that's our Math menu. And then we're supposed to go to Angle, which is the second choice down. Push to the side. Now it says P to RX. That means from polar to the rectangular x coordinate. So I did that. It's negative 2, 11 pi over 6, comma, 11 pi divided by 6. Surprised it didn't give me the actual value, because it should have cosine of 11 pi over 6 is going to be square root of 3 over 2, so negative 2 times that is negative square root of 3. So there's that value though, negative 1.9899. And then let's do the same thing for the y value. So I'm going to go to, again, second 5 gives me the Math menu, Angle, from polar to rectangular y coordinate, and we're doing negative 2, comma, 11 pi divided by 6. And so it gives me negative 2 times sine of 11 pi over 6. Well, sine of 11 pi over 6 we know is negative 1/2. Negative 2 times negative 1/2 is 1. And, oh, I know the problem. My calculator's in degree mode. Let's do those two over again. Okay, let's go clear this out. Okay, so once again, starting over again. Here we go. So we're doing second button, 5 gives me the Math menu. Push to the side, P to R of X. That's going to be negative 2, comma, 11 pi divided by 6. There we go. Gave it to me as the negative square root of 3. That was cool. That's what it should have been. And the next one, negative 2, comma, 11 pi divided by 6. So again, this is doing the y1 from the polar to the rectangular y coordinate is 1. So that was math to angle to polar arrow r sub x of negative 2 comma 11 pi over 6. That's negative square root of 3. Make sure it's in radian mode. That was my mistake. I had it in degree mode. Then math to angle, math menu to the angle menu to p dash or p arrow ry of negative 2 11 pi over 6, and that would give us 1. So now you can see how to do it on the calculator. We should be able to do it freehand anyway though. So the point is negative square root of 3 comma 1. Feel free to pause. Next one, the rectangular coordinates of a point are given. Plot the point and find two sets of polar coordinates for the point where theta is between 0 and 2 pi. So we're going to go with r squared is x squared plus y squared. So that means r squared is 4 squared plus negative 2 squared. R squared is 16 plus 4. R squared is 20. So r is the square root of 20, which is 2 times the square root of 5. And a decimal approximation for that would be, I don't have one on here. Okay, so 2 times the square root of 5. And by the way, 4 negative 2 is right there. So there's our r. Now tangent of theta is going to be y over x. So tangent of theta is going to be negative 2 over 4, which is negative 1/2. So theta is going to be arctangent of negative 1/2. And that's going to give us negative 0.4636. So that's saying that this angle here is negative 0.4636. So one point would be 2 root 5 comma negative 0.4636. Another point would be, if we were to look at it around here, pi later. So it would be not 2 root 5, but negative 2 root 5 brings it back down that direction. Negative 0.4636 plus pi. That's going to give us negative 2 root 5 comma 2.6780. Just adding that together. Now this asks for two values between 0 and 2 pi. This is the only one for theta being between 0 and 2 pi. This one is less than 0. So we're going to go further again, plus pi. So we'll take that negative 2 root 5 comma negative 0.4636 plus 2 pi this time, because that's plus pi, it's 2 pi later. And that's negative 2 root 5 comma 5.8196. So these are the two polar locations for this, with theta being between 0 and 2 pi. Feel free to pause that. I'm going to go on to number 4. Number 4, it says, use the angle feature of a graphing utility to find one set of polar coordinates for the given point in rectangular form. So we're going to go back to our graphing calculator here. Now this time, go to the math menu again. I just shut off right when I hit the button. Second math, angle. Now we're going to go r to PR. That means from rectangular to polar, the r, the radius. And our point is 3, negative 2. And that's square root of 13. And then let's do it again for the theta. R to P theta. That means from rectangular to polar theta. And that's going to be negative 0.58800. That's in radian form. So that our point would be square root of 13, negative 0.5880. And that's in polar form. So it's math to angle, math menu to angle menu to r to PR of 3, negative 2 gave us the square root of 13. Then math to angle menu to r to P theta of 3, negative 2 gives us negative 0.5880. Example 5. Convert the rectangular equation to polar form and sketch the graph. Well, just recall that x squared plus y squared is r squared. We don't have the plus, we have a minus here. Also recall that x equals r cosine theta and y equals r sine theta. So this x squared can be written as r cosine theta squared plus y is r sine theta, not plus, minus, squared equals 9. So r squared cosine squared theta minus r squared sine squared theta equals 9. So r squared times cosine squared theta minus sine squared theta equals 9. Now recall from your pre-calculus days that cosine squared theta minus sine squared theta equals cosine of 2 theta. So that means we can come up here and we have r squared times cosine of 2 theta equals 9. So r squared times cosine of 2 theta equals 9. I'll divide both sides by cosine of 2 theta. So r squared is going to be 9 over cosine of 2 theta. And r would be the square root of 9 over cosine of 2 theta, where r equals the square, well, it's 3. 3 over the square root of cosine of 2 theta. That's it. Not much more we can do with that. Okay, feel free to pause if you want. Okay, example 6. This is convert the polar equation to rectangular form and sketch its graph. So again, r squared equals x squared plus y squared, and r cosine theta equals x. So think about it this way. If I multiply both sides by r times r is r squared equals 5r cosine theta. So this r squared becomes x squared plus y squared. 5 times an r cosine theta is x. So you have x squared plus, or I should say minus 5x, plus y squared equals 0. So it's x squared minus 5x plus some blank plus y squared equals 0. So what's the blank going to be? Well, take half of this. We're going to complete the square. Negative 5 over 2 squared is 25/4. That's 0 plus blank. That's 25/4. So we have is x minus 5/2 squared plus y squared equals 25/4. So this is a circle with the center at 5/2, 0, and the radius is r equals 5/2, because the square root of 25/4 is 5/2. And if we're going to sketch the graph, here's our circle, centered at 5/2, 0, the radius 5/2. On to example 7. It says use a graphing utility to graph the polar equation. Find an interval for theta over which the graph is traced only once. Okay, so let's just come up with some values here. For theta equals 0, r would equal 3 times 1 minus 4 times cosine of 0, which is 1 there. That's 3 times 1 minus 4 times 1. That's 3 times negative 3, which is negative 9. For theta equals pi, r is going to be 3 times 1 minus 4 times cosine of pi. So I'm choosing values where cosine is going to be 1 or negative 1. There's 3 times 1 minus 4 times negative 1. Now 1 minus a negative 4 would be 1 plus 4, which is 5, so this is 15. 3 times 5, which is 15. For theta equals 2 pi. R is going to be 3 times 1 minus 4 times cosine of 2 pi. 3 times 1 minus 4 times 1. It's 3 times negative 3. So we're back to negative 9. So from 0 to 2 pi would be one full cycle here. Let's look at theta being pi over 2, where cosine is going to be 0. R is going to be 3 times 1 minus 4 times cosine of pi over 2. It's 3 times 1 minus 4 times 0. That's just 3 times 1, which is 3. And for theta being 3 pi over 2, r is going to be 3 times 1 minus 4 times cosine of 3 pi over 2. 3 times 1 minus 4 times 0. 3 times 1, which is 3. So we can roughly put these things on the graph. We go call this 3, 6, 9, 12, and 15. And for theta being 0, we're at negative 9. Theta being 0, we're at negative 9. For theta being pi, so once we're around here, we're at 15. For theta being 2 pi, we're back to negative 9. So 2 pi is back here, negative 9 is there. For theta being pi over 2, we are at 3. And for theta being 3 pi over 2, we're also at 3. So what does this mean? Starts here, I should say. And then it's going to go verify this real quick. Pi over 2 is there. Then 3 pi over 2, or pi is out here. And then we have our 3 pi over 2 is back at 3 again. Starts there, it's going to go to that point. I may have that circle wrong. It starts here, it's going to come out to that. Down to here, that's what it is. Then back there, back there. So there's our curve. Okay, on this, make sure you go to your mode, hit the mode button, make sure it's on polar, and then also make sure you're in radians. So I'm in radians and polar. So here it is, 3 times 1 minus quantity 1 minus 4 cosine theta. The window, my window's a little off. So do your theta min as 0, theta max is 6 point, that's just 2 pi, typed in 2 pi, they gave that to me. I do my theta step by pi over 24. My x min, let's go to negative 15 at least. X max, it doesn't need to be that much, we could say 5 by 1s. Y min, Y max, let's say minus 5 to 5. Let's graph it. Nope, not big enough. That just about does it. So it started here, came through up to that, around, and back again. Started there. So there goes to the upper curve, out and around, and back to there. Turn it that way. Looks like that symbol of the Bajor symbol on Star Trek. Okay. I bet no one got that joke. Moving on. Now my computer went to sleep on me. Let's go on to our next page. Side note, spiral of Archimedes is the graph of the parametric equations x equals 1/2 theta cosine theta and y equals 1/2 theta sine theta. This can be represented in polar form by r equals a theta. So a is just a number. So let's just, why don't we take a look at that while we're here. Let's just say 2 theta. And let's change our window to go something a little more rectangular, a little more standard. How about negative 10 to 10? And let's graph that. Oops. So it makes this spiral thing. That spiraled pretty quick. Let's go to, how about just theta? Oh, that's 0 to 2 pi. So if I take this and go out to like 10 pi, so it swirls out of control like that. Kind of cool. Continuing. Theorem 10.11, slope in polar form. If f is a differentiable function of theta, then the slope of the tangent line to the graph of r equals f of theta at point r theta is dy dx, dy d theta over dx d theta. That looks a lot like what we saw with the parametric equations. Equals f of theta cosine theta plus f prime of theta sine theta over negative f of theta sine theta plus f prime of theta cosine theta. So these two don't have derivatives, these are derivatives, provided that dx d theta is not 0. So it says, note here, solutions to dy d theta equals 0 yield horizontal tangents, provided that dx d theta is not 0. Solutions to dx d theta is 0 yield vertical tangents, provided that dy d theta is not 0. If dy d theta and dx d theta are simultaneously 0, no conclusions can be drawn about tangent lines. And theorem 10.12, tangent lines at the pole. If f of alpha equals 0 and f prime of alpha is not 0, then the line x equals theta is tangent at the pole to the graph of r equals f of theta. Okay, and then alpha is a point. So example 8, sketch a graph of the polar equation to find the tangents at the pole. R equals 3 cosine 2 theta. So we're saying that f of theta is 3 cosine 2 theta. Now we're looking at whenever r is 0. So looking at 3 cosine 2 theta equals 0. If we divide both sides by 3, cosine 2 theta equals 0. It means 2 theta must be pi over 2, which means theta equals pi over 4. Or 2 theta must be 3 pi over 2, which means theta is 3 pi over 4. Could also mean that 2 theta is 5 pi over 2, which means theta is 5 pi over 4, and 2 theta is 7 pi over 2, which means theta could be 7 pi over 4. So these are the places we can check. F prime of theta is going to be 3 times 2, because the derivative of 2 theta is just 2, times the derivative of cosine is going to be negative sine 2 theta. So that's going to be negative 6 sine 2 theta. F prime of pi over 4 it's going to be negative 6 sine of 2 times pi over 4, which is negative 6 times, well, 2 times pi over 4 is pi over 2, negative 6 times 1, which is negative 6. F prime of 3 pi over 4 is going to be negative 6 times sine of 2 times 3 pi over 4. Well, 2 times 3 pi over 4 is 3 pi over 2. Sine of 3 pi over 2 is negative 1. So it's negative 6 times negative 1, which is 6. F prime of 5 pi over 4 it's negative 6 times sine of 2 times 5 pi over 4. 2 times 5 pi over 4 is 5 pi over 2. Sine of that's 1, so it's negative 6 times 1 is negative 6. And f prime of 7 pi over 4 is negative 6 times sine of 2 times 7 pi over 4, which is negative 6 times, well, 2 times 7 pi over 4 is 7 pi over 2. Sine of that is, again, negative 1. So negative 1, we get positive 6 again. So tangents at the pole. Theta equals pi over 4, 3 pi over 4. So at pi over 4 and 3 pi over 4. At pi over 4, it's going to be negative 6. Let's call this negative 6. 2, 4, 6. At 3 pi over 4, it's at positive 6. At 5 pi over 4, it's at negative 6, so it's going to be back up here. And at 7 pi over 4, it's going to be 6. Okay. And let's see a picture of this. No, I don't like that one. It's like this. Let's go on to our last page then. Example 9, sketch a graph of the polar equation. A, r equals 1. Well, that just talks about the radius being 1. If you need to see it this way, you could say that r squared equals x squared plus y squared, so that r equals the square root of x squared plus y squared, so that the square root of x squared plus y squared is 1. The square root of x squared plus y squared equals 1. If we square both sides, x squared plus y squared equals 1. It's a circle with radius 1. So if I call this 1 here, it means we're just talking about this circle. So when you have r equals a number, you're just talking about a circle. I'm going to scroll up here. Pause if you want. R equals 1 plus sine theta. Now when I do these kind of graphs, let me lower that just a bit because part of the graph is too high. I come up with the angle first, so I do like 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, and then we have 5 pi over 3, 7 pi over 4, and 11 pi over 6, and 2 pi. So if you plug in 0, sine of 0 is 0, 1 plus that's 1. Sine of pi over 6 is 1/2, 1 plus that is 3/2, or 1.5. For pi over 4, sine of pi over 4 is 0.7071, 1 plus that is going to be just 1.7. For pi over 3, we're looking at 0.866, so I'm going to call this 1.87 if you add 1 to that. For 2 pi over 3, pi over 2 that's 1, so 1 plus 1 is 2. 2 pi over 3, again 0.866, so that's 1.87. We'll round to 2 places there. For 3 pi over 4, again 0.7071, so we'll say 1.7, 1.5. Sine of pi is 0, so 1 plus 0 is 1. Sine of 7 pi over 6 is negative 0.5, so that's going to be just 0.5, because 1 plus negative 0.5 is 0.5. 5 pi over 4, negative 0.7071, so we'll call that 0.3. 4 pi over 3, 0.8660, so we'll call that 0.13, excuse me. 3 pi over 2 is negative 1, we'll call that one 0. 5 pi over 3 is negative 0.8660, going to call that 0.13, call this 0.3, call this 0.5, and call this 1. Let's go ahead and graph this. We'll say this is 1 here and 2 there. So when theta is 0, we're at 1. When theta is at pi over 6, we're at 1.5. Right about there. When theta is pi over 4, we're at 1.7. Then we're at 1.87. And then we're at 2. So it's coming down, 1.87, 1.7, 1.5, and we're back down to 1 again. Then we're at 0.5. Then we're at 0.3. And 0.13, then 0. Then 0.13, 0.3, 0.5, and back to 1 again. So it's kind of like an upside down heart shape, kind of. It's not pointed. But this is called a cardioid. That's it for this section. Feel free to pause that and send me your questions. Thank you.